Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. I am welcoming you all to this beautiful online learning platform once again. Now we are happy to announce that Unacademy is going to providing online training for GATE and engineering service exams. About myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for their GATE exam. At present I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. Now first we check how to get Unacademy learning app into your device. Just go to Play Store and type Unacademy and it will show the Unacademy learning app like this. So by clicking on this install button, it will install the Unacademy learning app into your device. Now, here is a very important thing. So what you get? So by joining Unacademy, what you will get? First and foremost thing is daily live classes. Next, structured courses. Next, live tests and quizzes. Next, unlimited access. Unlimited access. Daily live classes. In daily live classes, see, first of all, the intention behind the conducting daily live class, conducting live class every day is to keep the student in touch with the subject. To keep the student in touch with the subject. That is the intention. And in that live class, you can chat with your educator. It means you can chat with your faculty. And you can engage in discussions. You can engage in discussions. And you can ask your doubts. You can ask your doubts. And you can answer the polls. So you can do all these things while class is going on. These are the things you can perform while class is going on. Next, structured courses. See, all our courses are structured in line with your exam syllabus. With your syllabus. That means your syllabus is well structured. It means what is the first subject? Has to prepare. What next? What next? What next? With your exam syllabus, every course is structured with your exam syllabus in detailed. Then it is very easy to the students, okay, for their preparation. After that, live tests and quizzes. Live tests and quizzes. In live tests and quizzes, you can evaluate your preparation with our regular mock tests and quizzes and get the detailed analysis on your performance. See, you can evaluate your preparation with our regular mock tests and quizzes. Regularly, we are going to conducting the mock tests and quizzes. By participating in that, you can evaluate your preparation. At the same time, once you attempted test and quiz, after completion of that test and quiz, we will give the detailed analysis on your performance in that test and quiz. Next, unlimited access. So once you take in one subscription, you get the access to all our live and recorded courses to watch from the comfort of any of your device. So it means once you take a subscription, you can get the access to all our live classes as well as recorded classes. What are the previous classes or courses completed, you can get that courses also. And you can watch it from any of your comfortable device. Okay, you can watch it from that. Now, there are two subscriptions, iconic subscription and plus subscription. Iconic subscription and plus subscription. Okay, see here, In Plus subscription, what are the things? Just before I explained, daily live classes, structured courses, live tests and quizzes, unlimited access. You get all these things. You get all these things in Plus subscription. This is the plus, and one more. Plus subscription is the basic subscription. So in basic subscription itself, you can get all these things. Sorry. Now, in iconic subscription, the benefits which are got by the Plus subscriber, you get all these benefits. You get all these benefits. In addition to this, you get personal coach and study tracker and mains question and answer practice. In addition to that, you get the personal coach. Okay, we allot a personal coach to you. Okay, see here you get one-on-one guidance from the top exam experts. Okay, he is acting as your personal coach, and once you attempted a test or quiz, it is going to be properly analyzed by your exam expert, that is a personal coach, and they will prepare a proper study plan based on your performance in that exam, and the respective study material also they will provide to you. So by following these two, every student can get success in their examinations. Next, study tracker. So you can evaluate your progress in bi-weekly reviews with personal coach. So you can evaluate your progress in bi-weekly reviews with your personal coach in study tracker. Next, mains question and answer practice. So you can strengthen your mains answer writing through regular practice with evaluation and personalized feedback. See, in mains exam, in engineering service exam, you need to write one mains paper. You need to attempt one mains paper. That paper, in that paper, you need to write the questions. The way how you are writing in semester exams, the same way you need to answer the questions. Descriptive manner. So you need a thorough practice for that, regular practice for that. Okay, so you can strengthen your mains answer writing through regular practice. So regularly you can practice, and we evaluate and we give the personalized feedback to you. So all these are the additional things you get in iconic subscription compared to Plus subscriber. These are the additional things. What are the benefits got by the Plus subscriber? You are getting all the benefits, but in addition to that, you are getting these things. Okay. Now, yeah, there is an Unacademy combat is written back in the month of May. Every Sunday you have an Unacademy combat. So for rankers, first rank 1 to 3, there is a complimentary Unacademy Plus subscription for 1 year. Rank 4 to 10, 75% of Unacademy Plus subscription for the tenure of your choice. Tenure of your choice. That means either you can take 6 months, 12 months, 18 months or 24 months. Tenure of your choice. And rank 1 to 11 to 50, 50% of Unacademy Plus subscription for the tenure of your choice again. And for rankers 51 to 100%, 25% of Unacademy Plus subscription for the tenure of your choice. These are the benefits you are getting if you get a good rank. Now, in this rank, in this exam, what you are getting, how you are going to be highlighting. See this, it is the India's largest weekly competition for GATE. You can assess GATE preparation in 60 minutes. Challenging and original GATE questions curated by the best educators. Challenging and original GATE questions curated by the best educators. Next, take it live to compete with the best, and super fast and fun with All India live leaderboard. So next, identify and improve your weak areas through detailed video solutions. Through detailed video solutions, you can do these things. Okay, these are the benefits you are getting. And these are the eligible batches: mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and IT departments. Okay. Now, these are the exam dates. Next combat is on May 2nd. After that, 9th, 16th, 23rd, and 30th. Every Sunday it will start at 11 a.m. Don't forget to use my code VRAO10 to unlock the exam. Now we are going to problems on MOSFET amplifiers. Problems on MOSFET amplifiers. Okay. Now, first, see this problem. Determine the bias current of M1 in below figure, assuming VTH, that means threshold voltage of that MOSFET is 0.5 volts, mu n COX is 100 microamps per volt square, W by L is 2 by 0.18 and lambda equal to 0. What is the maximum allowable value of RD for M1 to remain in saturation? Sir, before going to amplifier analysis, I am going to doing 2 or 3 problems on biasing. Okay, because the analysis what we are using in biasing is also going to use in amplifiers. Okay, now, so this is a self bias circuit, sorry, voltage divider bias circuit. First they want, so first you need to calculate the bias current. Bias current is nothing but a drain current or ID or IDS you need to calculate. Okay, IDS, and they are saying the M1 is remain in saturation. M1 is in saturation region. So once M1 is in saturation, you need to calculate IDS. So in saturation, we can write IDS is mu n into COX into W by L into VGS minus VTH whole square by 2. This is the equation for IDS. They given mu n COX, the 100 micrograms per volt square, W by L they given. The same time lambda 0. Lambda 0 means omit the channel length modulation. So VTH also they given 0.5 volts. Now we need to calculate VGS. For that, first I am taking the just whatever the input circuit here we have, I am going to replacing this part by its equivalent Thevenins like this. So this is the part. Now input side I am going to replacing this one by equivalent Thevenins. Like this. Let us take it as VGG. It is RG. And no need to calculate RG value because current through this one is gate current which is 0. This is the drain current ID. IS source current which is equal to drain current, we know that, and it is connected to the VDD 1.8 volts and this current also ID. So VGG we need to calculate first. So VGG is nothing but a, this is the VGG, voltage across 10 kilo ohm, supply is 1.8 volts. Just apply voltage division in this part of the circuit, apply the voltage division. By applying voltage division, calculate the voltage at this point. So that is 1.8 into 10 kilo ohms by 10k plus 4k. So that is the VGG value. Now get the value. How much you get? Simplify this. Simplify this. So 118 divided by 14. 1.286 approximately. 1.286 volts. That is the VGG. Now here I am going to getting the VS, which is a IS into 1K, and which is nothing but a ID into 1K, because IS equal to ID. And here I am going to getting the voltage at gate, which is the drop across this is 0. Now it is VGG, which is 1.286 volts. Now VGS is VG minus VS. Therefore VGS is voltage at gate minus voltage at source. Voltage at gate minus voltage at source. So now it is voltage at gate is 1.286 we got just before, minus VS is ID times 1K. ID times 1K. So this is VGS. Now substitute this VGS value in this equation for ID. Okay, now IDS is mu n COX by 2 into W by L into VGS minus VTH whole square. Substituting the value. Okay, take it as better to take this is by ID, no problem. Then it is easy to us because here also I represented that as ID. Now therefore ID is mu n COX, they given 100 micro amps per volt square by 2 into W by L is they given as 2 by 0.18, 2 divided by 0.18 into VGS 1.286 minus ID into 1K, that is a 1000 ID, minus VTH they given as 0.5. Just check. Yeah, it is 0.5. Simplify this, whole square it is. Now this 2 gets cancelled. Okay, it is a 10 power 4, 10 power 4, 10 power minus 4. So it is 1800. Then you get 1800 ID, 1800 ID is equal to 1.286, sorry, minus 0.5, that is 1.286 minus 0.5, it is 0.786. Minus 1000 ID whole square. Now I am going to applying the expanding this. So 1000 means it is a 10,000, sorry, 10 power 6 ID square plus 0.786 whole square, that is a 0.616, sorry, 617 approximately, minus 2 times AB. So it is 2 times 1000 ID into 0.786 minus 1800 ID equal to 0. Now this is our equation. Now, in this problem, I want to simplify this. Now it is a 10 power 6 ID square minus 2000 into, so 2 into 786, so 1800, that is 3372, 3372 ID. Just a minute, I think so. 10 power minus 4, so 2 it is 1800. Very good. Next, so it is a 3372 ID, including this, plus 0.617 is equal to 0. Now this is the second order equation in ID. Okay, now ID value is minus b, that means minus of minus 3372 plus or minus square root of b square 3372 minus whole square minus b square minus 4ac, c is 0.617 by 2a, 2 into 10 power 6. So now it is minus into minus plus, so it is a 3372 plus or minus square root of 3372 whole square, that is a 1,1370384 minus 4000 into 617, that is a 246 8000, 246 8000 divided by 2 into 10 power 6. So now it is 3372 plus or minus square root of is a minus 1,1370384. So it is a 8902384 divided by 2 into 10 power 6. So this is your ID, sir. This is your ID. Simplify this. Square root of this 29, it is a 3372 plus or minus 2983.68 divided by 2 into 10 power 6. 2 into 10 power 6. So now it is plus 3372 equal to divided by 2. It is a 1.68 milliamperes and 3372 minus 2983.68 divided by 2. It is 1.94. 1.94 milliamperes. So just a minute, I have some doubt here. That is a 3372 plus 2983.68 divided by 2. Yeah, it is 3.17, sir. 3.17. 3.17 milliamperes. So these are the values of ID. So ID has two values, but we need only one value. Therefore, required ID is minimum value of 3.17 milliamperes and 1.94 milliamperes. So small value is 1.94. Therefore minimum. Therefore ID is 1.94 milliamperes. That is the ID value. That is the ID value. Okay. Now, so far we calculated the ID value. After that, what is the maximum allowable value of RD? What is the maximum allowable value of RD? So, to RD for M1 to remain in saturation. So, I am going to copying this part. Sorry, it is 1K. Second part I am going to doing. So, required value of RD. So, about RD. Okay. So, to keep M1 in saturation, to keep M1, that means a device M1 in saturation. So required is VDS should be equal to VGS minus VTH. This is the requirement. And this is our circuit. So RS it is 1 kilo ohm. It is a VDD and it is RD. VDD. They given as 1.8 volts it is. Okay, input side RG and VGG. Okay, so this is the value of VDS. And the current through this one is ID, we know that. This is also ID, we mentioned already. Now, just I am applying KVL to this loop because to get the value of VDS. Okay, so from this, I got the value of VDS as, therefore VDS is VDD minus ID times RD plus RS. That's it. Okay, now, so VDD minus ID times RD plus RS is equal to VGS minus VTH. It should satisfy this condition. Okay. It should satisfy that condition. Now, I am substituting this. RS value they given 1 kilo ohm. And we got VGS value as VGS. Okay. Now, 1.286 minus ID into 1K. So, VGS is 1.286. So, VGS is 1.286 minus ID into 1K. Just substitute the value. 1. I do one thing, simplification. I am doing a different way. See, because to simplify the process, VDS can be written as VD minus VS is equal to VGS is VG minus VS minus VTH. Now, simply you can calculate VS, both these sides. Therefore, final relation is VD equal to VG minus VTH. So this is the VD, voltage at drain, is equal to, therefore voltage at drain can be written as, therefore VD can be written as from circuit VDD minus, so VDD is IDRD plus VD. So VDD is IDRD plus VD. Therefore VD is VDD minus IDRD. Okay, now I am writing that. Therefore VD is, voltage at gate already we calculated 1.286 something. Therefore VD is VG minus VTH. So VD value is VDD minus IDRD is equal to VG 1.286 something we got minus VTH 0.5. VD 1.8 volts minus ID we got approximately 1.92 something, previous 1.94 milli, and it is a 1.286, okay, 1.94 milli ID, 1.94 milli into RD is equal to VG 1.286 minus VTH 0.5. So 1.286 minus 0.5, it is 0.786, 0.786. Now take this one this side, this one this side, so minus 1.8, it is 1.014 equal to 1.94 milli into RD. Therefore RD is equal to divided by 1.94, that is a 0.522 kilo ohms. That is the RD value, minimum value of RD actually. Okay, so minimum RD value should be this much. Okay, or if you want to do one thing, simply better to take like this, greater than or equal to VD. Now this is VD, should be greater than or equal to, now RD is less than or equal to, because we are taking this one this side. So RD is less than or equal to 0.522 kilo ohms. Okay, now there is a problem in RD. We discussed about this in terms in amplifiers. By increasing RD, VD value is decreasing, but gain is increasing. Okay, but once to increase the gain, if you try to increase the RD value, now VD value is decreasing. Once VD decreasing, your device moving from saturation to linear region. That is the problem. Okay, so there is a the problem solved in MOSFET is not similar to the JFET, not that much easy. Okay, because you should maintain at the same time its region of operation also. Okay, so once we entered into amplifiers, then there you will understand this in a better way. Next problem. Now so now see the second problem. In the following circuit, assume M1 is in saturation. Okay, M1 is in saturation, fine, and RD value is 2 kilo ohms. They given RD value 2 kilo ohms. For my better, okay, next in that A bit, the maximum allowable value of W by L and the minimum allowable value of RS with W by L 5 by 0.8, 0.18. Assume lambda 0. Sir, lambda 0 means omit the channel length modulation. Now, so once they given RD 2 kilo ohms and voltage at this point is 1.8 volts. Okay, so first what I am going to doing is the device is in saturation region, they are saying. Now first I am writing condition to operate MOSFET in saturation. Condition to operate MOSFET. Default E MOSFET, sir. Enhancement N channel MOSFET. MOSFET in saturation is VDS is greater than or equal to VGS minus VTH. VGS minus VTH. Okay. In this problem, and you observed or not, previous problem and this problem both are same. So by simplifying this, I get the equivalent circuit. So same value I got 1.286 volts here. So it is 1 kilo ohm RS. It is RD, they given as 2 kilo ohms. 2 kilo ohms. It is 1.8 volts. Okay, whatever the value it is, it's not an issue. Okay, so this is the given data. And VGS. So in previous case, already we solved it. VTH they given 5.5 and we need to get the VGS value. Okay, so for that follow the same procedure. This is gate current 0. This is gate voltage 1.286 volts. This is also drain current. Voltage at source is ID into 1K. Okay, so nothing is different in that. So I am going to using the previous data. Whatever the previous data we have, I am going to using this. So sorry sir, oh, here one point is missing, that is use the data from problem 1. First problem. Sorry sir, the data was missed. Okay, now so this is next. So I got the same ID value 1.94, therefore ID is 1.94 milliamps. Only RD value changes, remaining all are same. ID is 1.94. So once ID is 1.94, sorry, voltage at gate. I do one thing, better to, I will try with this data only, just a minute. Yes, little bit confused. We check it first. There is a possibility. Voltage at drain greater than VGS minus VTH. Now in saturation, basic condition is VD is a VG minus VTH. And already we calculated voltage at this is VGG, that is nothing but a VG is equal to 1.286. Now I am getting that 1.286 minus 0.5 volts. Minus 0.5 volts. it is volts. Now it is 0.786 volts. Now we got the value of VD. So it means this is the value we got. So now I am copying this circuit. So VD is 0.786. So VD value is 0.786 volts. And this is the current ID. Therefore, ID is VDD minus VD by RD. Because we know the RD. In previous problem, we don't know the value of RD. We don't know the value of RD. But in this, we know that. Now it is VDD 1.8 minus 0.786 by RD 2 kilowatts. Now, by simplifying this, 507 microamperes. That is the value of ID. So once you calculate the ID from given data, now go to problem, whatever they want. First they want the maximum allowable value of W by L. Maximum allowable value of W by L. Sir, for all the problems default you can use this data. Use this data. Use mu n COX is 100 microamps per volt square. Okay. Now, first part I am going to calculate it. Maximum allowable value of W by L. How much? To get this ID. Now, we know the equation for ID. ID is mu n COX by 2 into W by L into VGS minus VTH whole square. Now ID we calculated ID 507 micro equal to, it is 100 micro by 2 into W by L. VGS is first we need to calculate VGS. So VGS is voltage at gate minus voltage at source. But voltage at gate 1.286 and voltage at source is ID times RS. Now 1.286 minus ID value is ID times ID is 0.507 micro into RS 1 kilo ohm they given. So this is, you get it as a kilo and sorry, it is a milli. Point, we are taking points, now it became milli points. Now these two gets cancelled. 0.5, it is a 0.779 volts. Use that. 0.779 minus 0.5 whole square. Okay, now micro gets cancelled. Now after simplifying, I'm simplifying. By simplification, you get it as 2 times 5. So by simplification, you get it 2 times of 5.0. 5.07 into 2 is 10.14. 10.14 by 0.779 minus 0.5 whole square. 0.0778. So 10 divided by 0.0778. Yeah, it is 128.5. 128.5 approximately. That is the W by L value. Okay, that is the W by L value. And second part is the minimum allowable value of RS with W by L. Assume lambda 0. The minimum allowable value of RS. Okay. Now, see, that means it should be in saturation. No doubt in that. So, we know the Now second part I am taking. Here ID value we are getting same thing, 507 microamperes. 507 microamperes. And the value of ID in saturation is, see, in our VGS we get, it is voltage at gate VGG minus VS is ID into RS, that is the VGS. Here we have RS. So first I get the VGS value. In saturation, we know the value of ID. ID is mu n into COX by 2 into W by L into VGS minus VTH whole square. Okay, from that I am going to taking this part this side and square root VTH also this side. Therefore we can write VGS is 2 times VTH first. This VTH plus square root of 2 times ID by mu n into COX into W by L. W by L. That is the equation for VGS. Okay. Now we know the value of VTH. They given 0.5. Okay, you can use previous values. So let VGS VTH 0.5. So 0.5 plus square root of 2 ID. 2 times ID is 507 micro divided by mu n COX 100 micro into W by L. They given the specific value of W by L, that is 5 divided by 0.18. 5 divided by 0.18. That is the value. That is the VGS. Okay, now VGS is 0.5 plus, it is micro, this one gets cancelled, it is a 5.07 into 2, it is 10.14 into 0.18 divided by 5 square root, that is 0.604 plus 0.5, 1.104. So 1.104. This is the VGS value. Okay. Now we can write VGS is voltage at gate minus ID into RS. Just before we mentioned. Therefore, from this RS is voltage at gate minus voltage at gate to source by ID. So voltage at gate, we know that 1.286 minus 1.104 divided by ID value. So we got ID 507 micro. 507 micro. Now get the value. It's 1.286. 0.18 divided by 507. That is a 358.6 ohms. So that is the resistance RS value. Okay. So this is also biasing problem. Now see the next problem. This one also in biasing. First you should be thorough with biasing, then only it is very easy to solve the remaining problems. Okay, you should be first thorough with biasing. Now calculate the drain current of M1. Calculate the drain current of M1 in the following figure. VTH is 0.5, mu n COX is 100 micrograms per volt square, W by L 5 by 0.18 and lambda 0. What value of RD is necessary to reduce ID by a factor of 2? Sir, here they did not mention the region of operation of FET, MOSFET. So first you need to calculate, you need to identify in which region it is operating. In which region it is operating. First you need to calculate. For that, I am going to calculate it. I am taking copying the circuit for identifying the region of operation. So the same circuit. So we know that this is the gate current. This is the gate current IG0. So once IG0 drop across this one is 0 volts. Once it is 0 volts, so whatever the voltage, here we have drain voltage VD and this is the gate voltage VG. So therefore VG is equal to VD. Once VD equal to VG, always VD is, so always VD greater than VG minus VTH. Therefore the given in circuit, therefore, okay, let us, I am giving some name to this M1 device. Therefore M1 is in saturation. Saturation. That's it. M1 is in saturation. Now in saturation, whatever the data, whatever the equation we have ID, just write that because we need to calculate that ID. Okay, drain current they are asking. So therefore in saturation, ID is mu n into COX into W by L into VGS minus VTH whole square by 2. Write on that, substitute the values. Therefore ID is mu n COX 100 micro by 2, W by L value 5 by 0.18, 5 by 0.18. So I think so. That's the meaning of this one is, it is a 180 nanometer technology they are using. 180 nanometer technology. Length of the channel is 180 nanometer. And VGS, this is a ID. This is voltage at source. This is VG. Is nothing but a VD. That is VDD minus ID times this is ID. So from this we can write voltage at gate is nothing but a voltage at drain, which is VDD minus ID times RD. ID times RD. Therefore which is VDD. VDD is 1.8 minus ID into RD value 1K. That is VG. Okay, and VS value is ID into 200 ohms. 200 ID. Therefore VGS is 1.8 minus 1000 ID. 1000 ID minus VS 200 ID, which is 1.8 minus 1200 ID. Substitute that. Therefore 1.8 minus 1200 ID minus VTH is 0.5 whole square. Okay, 0.5 whole square. Okay, now simplify this. Therefore ID, so it is a 10 power minus 4 It is a 2.5. 1800 by 2.5. 1800 divided by 2.5 is 720 ID. 720 ID equal to 1.8 minus 0.5 is 1.3 minus 1200 ID whole square. So this is the second order equation. Oh, sorry. Therefore, 720 ID equal to 1.3 square, which is 1.69 plus 1200 square is 14440 ID square minus 1200 into 2 into 1.3. It is 3120. 3120 ID. Now it is a 14440 ID square minus 3120 plus 720, that is 3840 ID minus 1.69 equal to 0. So this is the final equation. From this you need to extract the ID. From this you need to extract the ID. Okay. So what is the ID value? Just a minute. Okay. Now just to simplify this. Now get the ID value. So ID is minus B 3840 plus R minus square root of B square 3840 square minus 4AC 4A C 1.69 by 2A 10 power 4. Just simplify this. Three 3840 plus R minus square root of so 3840 whole square is 1474560 minus 4 into 1.69 into 1442340. That is a 9734400 by is 288 into 10 power 4 minus 1474560 and it is square root of that 2238.5. So that is a 3840 plus or minus 2238.5 by 2.88 into 10 power 6. Now we need the minimum value. For ID is a minimum value of this. So instead of adding this, I am going to subtracting to get minimum. Therefore ID is minimum. Minimum of two values what you get from this, ID1 and ID2. Therefore the minimum is this one. Directly I am writing. It is a minus 3840 divided by 3840 minus 2238.5 divided by 2.88. That is a 556 microamperes. 6 microamperes. That is the ID value. Okay, so therefore ID is 556 microamperes. That is ID. Next, so ID calculated. So far we calculated the ID value from this. Next, what value of RD is necessary to reduce ID by a factor of 2? ID reducing by a factor of 2. Now, say this. So, need to reduce ID. Need to reduce ID by a factor of 2. Factor of 2. Therefore, required ID is, in this case, required ID is ID by 2. That is 556 by 2. That is 278 microamperes. That is the ID value. With this ID value, to keep the device in the active region itself, what is the RD value? That is the required one. Therefore, now with this ID of 278 microamps. See, don't think about it is microamperes, because we are using the voltage of the order of 1.8 volts VDD supply voltage. In previous problems we are using a 10 volts, 12 volts, 5 volts, like that. Because of that high voltage there we got in terms of milliamperes. Now we are using very low voltage, that's why it is microamperes. So microamperes. With this idea of this much, to keep the M1, keep the device M1 in saturation, what is the value of RD? So now this is our requirement. Okay, so now it is 278 microamps. Therefore ID is 278 microamperes. So in saturation we know the ID value, mu n COX by 2 into W by L into VGS minus VTH whole square. Just substitute the values. So ID is 278 micro, mu n COX 100 micro by 2, W by L they given 5 by 0.18, 180 nanometer they are following. VGS voltage at gate minus voltage at source, it is 1.3 minus ID times 278 micro into RD plus RS from this subject whole square. Now just to simplify this gets you can cancel this micro, and so from this I'm writing directly. So it is a 0.4473 is equal to 1.3 minus 278 micro into RD plus, they given RS 200 ohms. Okay, applied square root also on this. Therefore, 3 kilo ohms is equal to RD plus 0.2 after simplification. Okay, 0.2K. Therefore, RD is 2.86 kilo ohms. RD is 2.86 kilo ohms. Okay, this is the way to solve this problem. Clear? So next one. Now calculate the small signal voltage gain of common source stage shown in the below figure. If ID is 2 milliamperes, VTH 0.4, mu n COX 100 microamps per volt square, W by L is 10 by 0.18 and lambda equal to 0. And verify that the M1 operates in saturation. So M1 is operating in saturation or not. They want to verify that one also at the same time. Okay, now, so first they want the voltage gain. So the voltage gain of this one is, we know that already we calculated, minus GM into RD. See this? Voltage gain is minus GM into small RD parallel with the capital RD. They given, need to omit channel length modulation. They given lambda 0. It means RD is, because RD directly proportional to 1 by lambda, approximately infinity. Therefore, voltage gain now required is minus GM times capital RD. They given RD value. It is 400 ohms. Now we need to calculate GM value. So what is GM? We know GM. GM is dou ID by dou VGS. Now first I am going to calculating that value. So in saturation, because they given it as an amplifier, in saturation, so to operate, to use your transistor as an amplifier, it should be operate in saturation region. So in saturation, ID is mu n into COX by 2 into W by L into VGS minus VTH whole square. Now differentiating that with respect to VGS, dou ID by dou VGS. This is nothing but your transconductance GM is equal to mu n COX by 2 into W by L is constant into, here is VGS. So 2 times VGS minus VTH into 1 minus 0. Now this 2 gets cancelled. Therefore GM is mu n into COX into W by L into VGS minus VTH. And here they given the IDS value, you observed or not, they given ID value 2 milliamperes. Now we need to get everything in terms of ID, this one also. Now from this I am going to writing VGS minus VTH is 2 ID by mu n into COX into W by L square root of, just to substitute that. Therefore GM is mu n into COX into W by L into VGS minus VTH is this one, square root of 2 ID by mu n into COX into W by L. Okay. Now just simplify this equation. So by simplifying this, GM is, this one cancelled in this by root times, square root of 2 into mu n cox into w by l into id. That's it. That is the GM value. Now I am calculating GM value. Square root of 2 into, the given mu n cox value 100, 100 micro into id 2 milliamperes into w by l. W by l is 10 by 0.18. 10 by 0.18. Just simplify this. Now this micro, this milli and this gets cancelled. 4 by 0.18 square root of 4.71. 4.71 amps per volt. This is the transconductance. Now just calculate the voltage gain. Therefore voltage gain AV is minus GM into capital RD. Therefore minus 4.71 into RD value. So what is the RD value they given? 400 ohms. 400 ohms. That's it. Now into 400. That is a 1885.6. Just a minute. Sir, just a minute. Sorry, it is milli, sir. We done mistake. Yeah. So you can't cancel this. Because, sorry, it is a milli and micro. Square root of 2 into 100 micro into W by L is 10 by 0.18 into 2 milli. Okay, now this 10, 100 and this milli gets cancelled. Now, so it is 4 by 0.18. It is square root 4.71 milli, because taking micro out of the square root it became milliamps per volt. Now go for voltage gain minus GM into RD. So minus 4.71 into 71 milli into RD is 400. So it is 0.4 into 0.4. That is 1.88 approximately. So minus 1.8856. So 88. That is the voltage gain. Okay. Next. And they given one more. They ask one more. Verify that the M1 operates in saturation. So what we need to verify this? M1 is operating in saturation or not? We need to verify that. Okay. So in saturation, see, in saturation, our VDS is equal to VGS minus VTH. From this problem, they given the circuit diagram. See this. Just take this circuit. From this is our VDS. VDS is VDD minus ID into RD. Now just write down that. So VDS is VDD minus ID into RD is equal to VGS minus VTH. Now VDS value is 1.25 Okay, sorry, this is a VGS. I'm sorry. VGS already we calculated 1.25. Sorry, this is just a minute. Now, so I'm going to substituting the values from this VGS minus VTH, also written as VDD minus IDRD. Okay, so it is, this is nothing but your VDS. So VDD is 1.8 minus ID value is 2 milliamperes they given, 2 milli into RD is 400 ohms. Now it is 800.8. Now it is 1 volt. Is 1 volt. That is the VDS value. Okay. VDS value is 1 volt. So once VDS is 1 volt, that is the value of VDS. Okay. At the same time, I am going to taking VGS minus VTH. VGS minus VTH. Voltage at gate minus voltage at source, VGS is. Okay, and first I am going to, we get the VGS value. So we know from ID I am calculating, we know the VGS, which is a VTH plus square root of 2ID by, previously we used this one, sir, mu n into COX into W by L. Just to substitute values. It is they given VTH is, I think so, 0.4 plus square root of 2 into 2 milli divided by mu n COX 100 micro into W by L value. So W by L value is a 10 by 0.18. 10 by 0.18. 10 by 0.18. Just simplify this. That is, you get the VGS value. Now it is a 2 into 2 milli. So this is a milli gets cancelled. 4 into 0.18. 4 into 0.18. Square root of it. It is 0.848 plus 0.4. That is 1.248. 1.248 volts VGS. Now I am going to taking this. Therefore, VDS we calculated just before 1 volt. VGS is 1.248 volts, and we know the VTH value, that is 0.4. Now I am calculating VGS minus VTH. 1.248 minus 0.4, that is 0.848 volts. So therefore VDS is greater than VGS minus VTH, because it is 1 volt and it is 0.848 volts. So VDS is greater than, therefore your device is operating in saturation. Now it is in saturation, fine, but how much margin? See, this margin is very small. Okay, therefore now the margin is small, 0.15 volt, 151 volts. It's a very small margin. Okay, if it is increasing or if it is decreasing by a value of 0.151 volt, then automatically your device is going to be entering into linear region or triode region. So that is the problem. Okay, if your device is entering, if your VDS is decreasing, VD value already we defined, VDS is a VDD minus IDRD. In this, just see this. For example, no, we are not disturbing the supply. Now ID they fix. If RD decrease, if RD increase, then VDS decrease. Once VDS decrease, device M1 is in linear region or triode region. But you may ask one thing. So if you are going to increasing RD, gain is increasing, fine. But your device is no more in active region, no more in saturation region. It is coming out of the saturation and entering into the linear region. That is the problem. So while you are going to designing a FET amplifier, MOSFET amplifier, okay, you need to care about, you need to compensate both gain and region of operation. Both should be simultaneously, you need to compensate. Okay, that is very, very important. Is it clear? Next. So next problem. See, assume M1 is operating in saturation. Fine. This is M1, it is operating in saturation. Determine the voltage gain of the circuit shown below. Voltage gain of the circuit shown below. Okay, see. Now, this is similar to the common source amplifier with, instead of RD, here we have current gain. So here we have a current source. Here we have a current source. So there is no RD. RD is infinity compared to regular circuits. And this is the current source. Now, this current source, it gives a infinite small signal resistance. Infinite small signal resistance. Okay, it gives infinite small signal resistance. Now let us take the small, it gives a very high value. Let us, it gives practically, but practically it gives something. Now its resistance is R0. Let us, now this device is having some R0. Output resistance of this device is having some R0. Some R0 it has. We call it as a drain resistance. Now its voltage gain can be simply written as minus GM into R0. Simple. Otherwise, do the procedure. Gate side, gate we have input. Now I am going to calculating the voltage gain of this. See this? Now this is open circuit because its in resistance is in infinity. Okay, now gate, this is gate, source, gate. Here we are connecting input, source, it is VGS, and it's a small signal equivalent, GM VGS. Here we have RD. This is output. Okay, this is output because it is open circuited. Current source is open circuited because it gives infinite small signal resistance. That's why it is open circuited. Now, so it is ground, source connected to ground. So this is GM VGS. Now the same current is flowing like this, GM VGS. Therefore output voltage is minus GM VGS into RD. Okay, but input is VGS, is nothing but a input. Therefore voltage gain is V naught by Vi or V input, which is V naught by VGS, which is minus Gm into Rd. Here I am calling Rd as R naught. Rd as R naught. So minus Gm into Rd. That is what we've written there. That is what I mentioned there. Is it okay, sir? Okay. Now, next problem. Yeah. Now, below figure shows the common source stage using a current source load. Current source load. Compute the voltage gain of the circuit. Compute the voltage gain of the circuit. Okay, first I am going to taking this part. I am going to calculating this first. So here now first what I am doing is, this is you observed or not, it is a PMOS and it is NMOS. Okay, PMOS and NMOS. First we need to calculate amount of, it is biasing voltage. VB means biasing voltage. Biasing voltage. Okay. Now, once it is biasing voltage, under general conditions, you can short circuit to ground in AC analysis. Now, here I am going to calculating its output resistance in this direction. Its resistance in this direction is the amount of equivalent resistance given by this one is simply its output resistance R01. It is nothing but RD1 what we mentioned. Okay. Now, because I am assuming lambda 0, I am omitting channel length modulation. Sorry, considering channel length modulation, because they did not specify, I think so, they did not specify the about any channel length modulation. Okay, that's why. Okay, now otherwise do one thing, just replace every device by its small signal equivalent, then we get the detailed information. So directly also you can write it is a common source minus Gm into R02 parallel with R01. This is the voltage gain. This is the voltage gain, required voltage gain. This is your voltage gain of the circuit. Now we check it how it is. First I am going to replacing this by its small signal equivalent. Now it is biasing voltage, VB is, therefore gate 1 connected to ground, source 1 also connected to ground. It is a drain 1, it is R01 or RD1 as you wish. Or it is GM VGS1. This is our VGS1. You observed or not, both are connected to ground. So VGS1 is 0. Once it is 0, it became open circuited. Now it is drain 1 connected to ground through RD1. Very simple. Okay, now it is like this. Now it is V input, it is VDD. So at source we ground and taking output. So at drain you are taking output, At drain you are taking output for this PMOS. At gate you are applying input. Therefore it is common source amplifier. Therefore it is a common source amplifier. Load is D1 or D1 load. Therefore its gain is minus GM into GM2 into R02 output resistance of this R02 parallel with R01. That's it. This one and this one both are same. Okay. Next. This is also same way, sir. But here it is acting as a load because it is biasing. It is acting as a load and it is acting as the same. Now its voltage gain is minus GM1 into R01 parallel with R0. Sir, in last GATE exam, they given the problem on, based on this model, they given the problem. They given the direct amplifier common gate source, but in terms of, they did not given any load directly. Instead of giving a load, they given in the terms of devices. Okay. Now, sir, we have few more problems. So next session we solve the remaining problems. So now here are the top educators from Unacademy. Tiwari sir, he is IIT topper. He has 7 years of GATE and ESE experience, ESE teaching experience. He is author of the book GATE in 75 days. And Ankit Goyal sir, he obtained All India first rank twice in GATE Electrical, and he was awarded President of India Gold Medal in IIT Indore. Okay, and he teaches the electrical and electronics engineering. Sanchit Jain sir, he is the computer science faculty and having experience of more than 8 years. And Jaspal Singh sir, he is the ex-IAS officer and he got All India 4th rank in that, and he is the scientist, GATE, State Service Exams and PSU topper and ex-senior MEDISE faculty. He has more than 12 years of teaching experience. Here are the few more top educators from Unacademy. And see, these are the different disciplines available from Unacademy for GATE and engineering service: electronics and communication engineering, chemical engineering, mechanical engineering, computer science and IT departments, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. So now there are two subscriptions, Iconic plus two plans, Iconic plan and plus plan and Iconic plan. Plus plan is the basic plan. Iconic plan, it will take your GATE and ESE preparation to next level with personal coach. Now it is the India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. Here also same thing, just before what I explained. But once you've written the exam in Iconic plan, it was forwarded to your personal coach. You do the analysis on your performance in that exam. That is called personalized test analysis. Based on that, they prepare a proper study plan to you, and respect to study material also they will provide to you. By following these two, every student can get success in their examinations. Now in plus plan, different subscriptions: 1 month, 3 months, 6 months, 1 year, 1.5 year and 2 years. For 1 year it is 30,250. By using my code you can get it by 10% discount. My code is VROUT10. Next, in Iconic plan there are two subscriptions, 1 year and 2 years. For 1 year it is 50,250. By using my code VROUT10 during subscription you get it by 10% discount. And the beauty is here EMI option also available. Next, see, don't forget to use my code VROUT10 and hit the bell icon for getting notifications. Please give your valuable comments on YouTube. Don't forget to subscribe us. Join our Telegram group for getting latest updates on our upcoming videos. Thank you very much. Thanks for spending your valuable time with us. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Thank you.